Hello guys, this is a small tutorial about testing of sequential circuits wherein you have a lot of problems like the testing of internal nodes. If you can see the screen here, I have a RTL of some random circuit wherein I have some primary inputs. If you can see the mouse, these are the primary inputs which are available. By primary inputs I mean the inputs which are directly available to me, wherein I can give the inputs. For example, this one, the this present input, this one, and this. All these are primary inputs by which I can give the test inputs. Let's consider this AND gate for example now. The inputs, if I want to test this particular AND gate, all I need to do is to just give this input, which is directly the primary input, give this input, which is again the primary input, and then I can directly give the inputs to this particular gate. If I consider this AND gate now for example, this is also connected directly to the primary inputs, this one and this one. So I can directly give the inputs to this gate too. Now let's consider this AND gate now, the third one. Here as you can see, I don't the inputs to this gate, that is this input and this input, they are not directly connected to the primary inputs. So it means I don't have any controllability on this particular gate. I can't have any control on this gate, and it is internal to the design, and I cannot even observe the output of this particular gate, so I can say the observability is 0. So in such a case where I have a design where I want to test a gate or any logic which is present within the circuits, which is internal and which cannot be controlled by the primary inputs, then we go for sequential design. Let's take this particular sequential, how it is designed. A sequential is nothing but a simple D flip-flop which has been modified to operate in two types of mode. For example, let me double click this sequential. I double click it. Now you can see that within the sequential there is a mux and as usual the D flip-flop. I have just added a mux in front of a D flip-flop, and this D flip-flop has the input a clock which is directly from the main clock as you can see, and the output from the mux. And this mux has two inputs, one directly coming from the AND gate and another coming from an input called as the scan input, which is here the scan input. Now there is, in order to select either the input from the AND gate or the input from the scan input, which is one of the primary inputs, now there is a select line. This is a select line as you can see. This select line, when it is 1, it will take the inputs from the scan enable, that is the scan input, and when it is 0 it will take the input from the normal AND gate. So when we make scan enable signal is equal to 1, when you make the scan enable signal is equal, let me just zoom it out for you. Yeah, here is the scan enable signal. When I make this 1, the circuit is now set to be in a test mode. It means I want to test a circuit. Now what I'm exactly trying to do is, when the scan enable is 1, the input are from scan input, it goes here and it goes here and it comes out from the output of the D flip-flop. What I have done is I've just made a cascade connection between all the D flip-flops. If I'll just zoom it out. Okay, as you can see, the output of this cancel is connected to, you can see the output of this is connected to the input of this, that is the scan input of this, and the output of this is been connected to scan input of this. So and the output of this is connected to input of the AND gate. Just if you notice it clearly, let me zoom it out. The output of this flip-flop, second flip-flop, is connected to third. The output of third is connected to the input of the AND gate, which I want to test now. Let's see output of the first cancel. It is connected to the first input of my AND gate, and output of my third cancel is connected to the second input of the AND gate. Now, because this cell and this cell are connected in cascade, and they are connected in cascade only when I make the scan enable signal, this one is equal to 1. When I make this one, it becomes a simple scan cell where the inputs which are given here, they get shifted one by one for every clock. For example, if I make the scan enable 1, they are in cascade now. The output of this is given to output of this, output of this goes to output of this, and output of this get applied to input of this, right? Now I apply a scan input, let's say 1. I apply a scan input signal 1 and make scan enable is equal to 1, which means it is in the cascade mode, the scan mode. And when immediately when I apply a clock cycle, 1 clock cycle, what happens? The scan input of this comes here, the output of this comes as output of this. Indirectly, when the flip-flops are in cascade, they act like a shift resistor. If I apply 1 here and apply on clock, that one appears output here. Now next, let's say I applied 0 here and applied one more clock. The one which was present here comes as the output of the second scan cell, and 0 comes as output of the first scan cell. Now let's say I apply one more 1 here and applied one more clock. The one which is present here comes as output of the third scan cell, and output of this comes as output of the second scan cell, and the input appears as the output of the first scan cell. So they're just shifted. Now after shifted, if you can just see, after 3 clock cycle and 3 test inputs, you're actually given the inputs to this AND gate. Let's say that I have given 101, and applied 3 clock cycles. The one will be here at the output of the first cancel, which is also the input to this AND gate. So I applied indirectly 1 to this AND gate, and output of this cancel, that is this, is 1 now, which is nothing but input of the AND gate, which is the second input. So indirectly I applied 2 inputs to AND gate, and that is what I wanted. I did not have any control to give inputs to this particular AND gate, and now by using the scan cells and making scan enable 1, giving the scan inputs and applying 3 clock cycle, I have set up my AND gate inputs to 1 here and 1. So what do you expect the output of the AND gate to be now? It has to be 1, right? It has to be 1. Now if I make scan in, let's say the output of this is 1 now, but it will not be captured in the sense it will not be stored in this scan cell, because the scan enable is still 1 now. Let's say now I have made scan enable is equal to 0. Now the circuit will operate in its normal mode. It means it is not anymore a test circuit. It is a circuit for which it was designed. Make scan enable is equal to 0. Give the primary inputs whatever you need. Give A1, A2, right? And here give A3, A4. What happens when you make scan enable is equal to 0? It will operate in the normal mode, and this AND gate will also operate with the test inputs which you had given. You had given 1 1. Now that 1 1 has given the output 1. If this is not faulty, it will give some other output. If it is fault free. Now I just want to see whether for given 1 and 1 to this input, whether it has given 1. How I can do this? Now what you have made? You have made scan enable is equal to 0. The primary inputs have been applied. Now after making scan enable 0, after applying the primary inputs, now apply 1 clock cycle What happens? the in the output of the combinational gate, that is output of this gate, get captured in this cancel. Output of this AND gets captured in this cancel. Output of this AND gate get captured in this cancel. Correct. Now I make scan enable is 0 and apply one clock. Indirectly you have captured the output response of this AND gate, which is under consideration now in the scan cell number 2. It is captured. Now I want to see, if you want to see this output is 1 or 0, directly you can take the output from Q, but Q is the output of the circuit. We have made a provision to see the scanned input and scanned output by giving another output called as scan out here. Now if I apply one more clock cycle and make scan enable is equal to 1, what happens? When I make scan enable is equal to 1, once again they will act like shift resistors. The output of x1 will come to output of x2, output of x2 will come as output of x3, right? So if I apply one more clock cycle after scan enable 1, the captured response of AND gate at x2 will appear at output of x3, and which is available at s0. If this output is 1 now, it means my this AND gate is fault free. If it is 0, I can say this one is failed. So this is how we can test any internal circuits, any internal gates with the help of scan cell. Let us have a look at the simulation result. Here I have written the code for this particular configuration and made the test modes. Let's go and check. Okay, here is the simulation. I have written the test bench for that. Just run this. Okay, wait for the results. Okay, just increase the time run. Okay, here is the setup. Okay, here we come. You can see this is my first clock rising edge. In the first rising edge, what is my scan? I have made scan enable is equal to 1. As you can see, I have given the first scan input as 1. Second clock cycle, the scan enable is 1, scan input is 0. It means my second scan input is 0. Third clock cycle, scan enable is 1, scan input is 1. It means after 3 clock cycles, I have actually given 101 to be present at the output of my scan cell 1, scan cell 2 and scan cell 3. Indirectly, I have set the input of the first AND gate to be 1 and second input also to be 1. That is what I require. That's why I have shifted 1, 0 and 1, so that the first and the last becomes 1 and 1 get applied to my AND gate. Let's go again back to the simulation. Okay, so after this first clock cycle, second clock cycle, third clock cycle, I have made scan enable is equal to 0. Here you can see the scan enable is 0 now. It means now the responses are captured. You go to the RTL, it means the output of this gets captured here, output of this AND gates get captured here, output of this AND gate gets captured here. Now after making scan enable 1, I have applied one more clock, right? One more clock, but still the scan enable is 0. It means I am capturing the response. Here again what I have made scan enable is 1, making it once again a shift resistor and applied one more clock. After this clock, what do we expect? The response which is captured in x2, that is nothing but the response of AND 2, will appear at the output of x3, which is available at s0. Let's see whether at s0 we have 1 or 0. At s0, here you can see it is 1. It means my AND gate is working perfectly. This is how we can test any circuit in general, and we can test the internal gates whether they are properly functioning or not. Scan cell is mainly used to test for hardware faults like a circuit open or a circuit close. If you want still interested in going about experimenting this, you can take the test bench circuits like the ISAC S27 which I used here, ISAC, and I written let us go to the RTL of this as a more complex design which is available, which are also called as the test bench circuits. And let's run the RTL. My idea is to just show you how big can a sequential circuit be, and how to convert that design to a scan cell design. Okay, my RTL is ready. Okay, fine. Here you can see it's a bigger circuit now. Wherever I find D flip-flop, I have to just replace it by cancel. See, here there was a D flip-flop. See, this is a D flip-flop. I replaced it with my scan cell. Here is also there was a D flip-flop. I replaced it by my scan cell. And this is how you can convert any circuits from a normal circuit to a test circuit. You have to just identify where are the D flip-flop present in your design and then replace that D flip-flop with your scan cell. The main thing which you have to do is to properly make sure that when scan enable is 1, the scan cells are in cascade. They must act like shift resistors, and when scan enable is 0, you must not alter the design of your circuit. And that was a short tutorial about scan cell design. For more details, you can log on to my blog verilogcode.blogspot.in.